Very well. Today, we are going to learn how to graph linear inequalities and determine the possible solutions of these inequalities. So we are going to start with something very well. The most important part to remember today is that everything that we're going to talk about will only work when y is by itself on one side of the inequality. And it's also going to be very important for us to understand what the inequality symbol is telling us about y. Like in this case, we are being told that y is less than whatever is on this side. Also be aware that it's possible that you have something like this. This is also saying that y is less whatever you're gonna find on this side. Here we're saying that y is gonna be less of whatever you have over here. So what I mean is those two mean exactly the same, and that's what we're going to focus. Over here on the second one, we have y is greater than whatever you're gonna find here. So what I mean by that is that if I have y on this side, but my symbol still points to the greater side, to the y, this and this will mean exactly the same. Then here we have y is less or equal. So remember that'll be the same if the y appears on this side. The left side still points to the y, and you still have your equal under. This one is saying the y has to be greater or equal to whatever is over here, which is the same if I have my y on this side and I have the greater side pointing at it and also the equal. So the most important part right now is to remember that y has to be alone on whichever side. Now, in the first example that we have right here, we have that y is less than whatever is here. So, in an inequality, there's always a part of your graph that is shading. The symbol, the inequality symbol, will tell you what is it that you need to shade. In this case, since they tell me the y has to be less than whatever we have here, you're going to draw your line like you normally do, and we're going to talk about that in a little bit. But if we are being told the y is less, it's because we are going to shade everything that is under the line that we have. Okay? So for example here, I'm being told that y, it's also less. We're going to talk about the equal part in a minute. So in this case, I am also going to shade under. Okay? Now, here I'm saying the y is less than whatever, that's why I'm shading under. Here I'm saying the y is less than whatever, that's why I'm shading under. But there's a difference between these two. Here I have a dotted line. Here I have a solid line. What is the difference? Here I'm being told that y is less or equal. So that solid line means that whatever I have on this line, any points that we have on this line, they are allowed in my solution. That's why the solid line represents. Now here, my y is less than, only less. That's why I put a dotted line. That means that this line is sort of imaginary. It's there just to tell you the boundary, but we cannot use any of those points. So for this one right here, we are going to say that the characteristics of this, we have shaded under, so under the line. Here we also have shaded under. Now here we have a dotted line. And here we have a solid line. So, very good. Now, you still might be a little confused. So this is what we are talking about. The shaded area, the reason why it's important for us to know where we're supposed to shade is because that represents all the points that are going to be part of the solution. Example, let's start with this point right here. 5, 5. The point 5, 5 is 5, 5, right there. This point is in the shaded area, so we say this is a solution. So that means that that combination would work in whatever inequality I have. Right now we're just talking general, we don't have numbers. Then we have this point, 0, 0. The point 0, 0 is this one right here. That is also in the shaded area, so we say yes, it's part of my solution. Then we have this point right here, 0, 3. 0, 3 is right here. Now this point is exactly on the dotted line. So when it's on a dotted line, this is not part of my solution. So I want you to understand the difference. We're going to look at this one right here. So we're going to start again with 5, 5, which is this one right here. And yeah, we have right there. And it's in the shaded area, so yes, it's part of my solution. Then I also have 0, 0, which is going to be this point right here. And yes, it's part of the solution because again, it's in the shaded area. But then at last, I have 0, 3, which this time 0, 3 is right here. It's just that now we have a solid line. What does that mean? That this is part of the solution. So the solutions are going to be any point that is on the shaded area or in a solid line. Dotted lines do not count. So now I want you to pay attention to this one right here, the next one. We have the y is greater. When we say that y is greater, is because we are going to shade on top. So if we actually look at this one right here, you see how we are also saying the y is greater. So we're going to shade also on top. Now what is the difference between this one and this one? Here we have a dotted line because we don't have an equal in my symbol. Here I have an equal in the symbol. That's what that line under means. That means that I'm going to have a solid line. So every time that I see this symbol right here, I know that number 1, I'm going to shade above because y is greater. But since I don't have the line under meaning equal, this is going to be a dotted line. Now in this example, we are still going to shade above. Why? Because if y is greater, we're shading above. And since now I have the line under that means equal, we have a solid line. Now how would that affect our solutions? Let's start from the beginning. What about 5, 5? 5, 5 is going to be right there. This is not in the shaded area, so that is not a solution. Then we have 0, 0, which is right here. And that is not in the shaded area, so it's not part of the solution. Then we have, 0, 3. And 0, 3 is right here in a dotted line. And remember, dotted lines are not allowed, so this is not a solution. Now let's look at this one right here. This is my graph. First, let's start with 0, 0. 0, 0. 5, 5 is right here. Is that part of the solution? No, because it's not in the shaded area. Then we have 0, 0. 0, 0 is right here. Is it part of the solution? No, because it's not in the shaded area. Then we have 0, 3. 0, 3 is right here. This is actually on a solid line, which means yes, it's part of the solution. So for you to find a solution, it's either going to be on the shaded area or on a solid line. So this is the general idea, but what's going to happen when we have actually an inequality, such as this? I want you to understand the difference between having an equation, an equal sign, and an inequality, like this one. I just chose greater than just for this example. The biggest difference is that here, when we have an equation, we have a solid line, and only a solid line. Now, what happens over here in my inequality? Well, first of all, I have shaded area. In this case, is shaded above. And then sometimes I have solid, sometimes I have dotted lines. In this case, I have a dotted line. Now, what does the dotted line mean? That if I have a point on that line, it is not going to be part of my solution. So, let's recap that a little bit. Let's start by checking this. Is this point part of the solution? For my equation, 2, 2 is 2, 2. That point is on the line? Yes, it's a solution. Now, what about the point 3, 5? 3, 5. That point is not on the dotted line, and there's no shaded area. So this is not a solution, because it's not in a line at all. We only have a solid line. That's the only thing we care. Then for the next one, we have a 0, 0, which is this point right here. Now that point is on the line. It's part of my solution. Then at last, I have the point -1, -4. -1, -4, right here. Sorry, right here. Is that part of the solution? No, because it's not on the solid line. Now let's compare that to the inequality. So first I have 2, -3. So 2, -3 is right here. Is that a solution? No, because it's not in a shaded area, it's not in a solid line. Then I have 3, 3. That point is 3, 3, right here. Now that point is on a dotted line. It is not a solution because only solid lines are part of my solution. Then I have 0, 0, which is this point right here. Again, I'm on the dotted line. That is not a solution. At last, I have the point 0, 5. That point is here. Is this a solution? Yes, because this is in the shaded area. So before we were talking about linear functions. In linear functions, my solutions is only points that are along the line. But now that we're talking about inequalities, we are shading, and the shaded area represents the possible solutions. And sometimes if I have a solid line, if I have points on that solid line, they will be part of my solution as well.